Welcome to Study Loop.
Okay, so this is the free body diagram for the package A. Okay, so we know the net force along the surface should be equal to FBC plus WA sine 15 degree, which is WB plus WC times sine 15 degree plus WA sine 15 degrees, which is 3WA sine 15 degree. Okay, since WA is equal to WB is equal to WC, which is equal to 4 kilogram times 9.8 meter per second square, and this will give us 39.2 Newton. Okay. So eventually we can determine the net force along the surface, which is F net is equal to 3 times 39.2 Newton, and then times sine 15 degree. And this will give us the net force is about 30.44 Newton. So now let's take to get the maximum friction on the package A, which is mu Sn, which is mu SWA cosine 15 degree. And we know mu S is equal to 0.30. So therefore we have 0.30 times 39.2 Newton, and then times cosine 15 degree. And this will give us the static friction, or the maximum friction is about 11.36 Newton. Okay, which means that the net force along the surface is greater than the maximum friction, which means that the package A will move. So now let's determine the actual friction, which is the kinetic friction. So the kinetic friction Fk should be equal to mu Kn, which is 0.20 times 39.2 Newton, and then times cosine 15 degree. And this will give us 7.57 Newton. Okay, so this is the actual friction on package A. And this is the free body diagram for package C. And we know the net force along the surface for package C should be FB plus WC sine 15 degree minus FA, which eventually will have F net is equal to WC sine 15 degree, since WA is equal to WB equal to WC. Okay, so therefore let's determine the net force on package C along the surface, which is equal to 39.2 Newton, and then times sine 15 degree. And this will give us the net force is about 10.15 Newton. For the next part, we gotta determine the maximum friction on package C, which is static friction here, which is mu Sn, which is equal to mu SWC cosine 15 degree. If we plug in the values, we have 0.30 times 39.2 Newton, and then times cosine 15 degree. And this will give us the maximum friction is about 11.36 Newton. As you can tell, the net force is less than the maximum friction, which means that package C will not move. Okay. And for the free body diagram of package B, this is the free body diagram for package B. And as you can tell, FAC, which is the normal force from package A and C, should be equal to WB sine 15 degree because they are action-reaction pairs. Okay, so therefore we have the net force along the surface on package B should be equal to 0, which means that F net is less than the static friction on the package B. So therefore it will not move. Okay. If it's not moving, that means there's no friction acting on it. Okay, and these are the answers for this question.